Good morning, students. I am Dr. P.S. Kaushik, Principal at Sri Digambar Institute of Technology, Dausa, Rajasthan. This is my 23rd lecture on the subject Engineering Mechanics. This subject belongs to Civil and Mechanical Engineering in the third semester of RTU. Today's topic is Centroid and Center of Gravity. Today I will be discussing the basics or fundamentals of center of gravity and centroid. As all we know that a body is composed of number of particles which are attracted towards the center of the earth due to gravitational force of attraction. These lines of forces are in actual concentric but centered to the center of the earth as shown in the figure. You consider this is a figure and you can see that this is these all lines are concentric towards the center of the earth. These lines forces are in actual concentric but from practical point of view considered parallel since the distance of center of earth is far distant and the concentricity seems fairly parallel. The center of gravity is the point through which the force of gravity acts on an object or system. The center of gravity CG is of an object is the point at which weight is evenly dispersed and all sides are in balance. In mechanics, the gravitational field is assumed to be uniform, hence center of gravity is in exactly the same position as center of mass. The center of gravity, the centroid or geometric center of a plane figure is the arithmetic mean position of all the points of the figure. Informally, it is the point at which a cutout of the shape could be perfectly balanced on the tip of a pin. Okay, now let me discuss what we have read till now. Here, what I am telling that center of gravity is the point at which whole weight or mass of the body is considered to act. If the body is contracted and bring into a particle, then we can say the point at which whole mass or whole weight is considered to act. Now, as we all know that the lines of forces are acting on a body and this is the earth center and we can say all these lines are going towards the center of the earth like this. But because the center of earth is thousands of kilometers from the surface, so we can consider that the lines of forces are virtually parallel. So we can say that these lines of forces are like this. Now we can consider these forces, line of forces. Now if I start that is to concentrate this figure to a smaller one and bring it to a point, then the point at which whole mass or whole weight can be balanced, then we can say that point is the center of gravity or center of mass of the body. Now, the center of gravity is the term when we use when mass or weight is considered. For a plane surface, say this is the area, a plane area this is here. If I just start contracting this area, a point is reached, that point we will be calling that it is the centroid or geometric center of the plane figure. That is plane figure. It can be line, a volume, or a area. Features of center of gravity. A body has only one center of gravity. Its location does not change irrespective of the position or orientation of the body. Since whatever is the orientation of the body, the relative position of mass of the particles of the body does not change, hence the position of center of gravity also does not change. The position of center of gravity depends upon the shape of the body. It always lies in a plane of symmetry of the body, if any. If there is any symmetry, then it will lie always in the central line or symmetric line of the body. A plane of symmetry is the shape through which the body such that the mass distribution is symmetrical on either side of the plane. It is an imaginary point which may lie within or outside of the body depending upon the shape of the body. Okay, now let us discuss all these 5 points. A body has only one center of gravity. It is always a fact. A human body is generally has a center of gravity at the central point on the stomach. Similarly, every body has a center of gravity. It is unique. It will not change irrespective of the orientation or position you bring the body. Now, consider you might have seen a eagle shaped toy like this. This is a toy like this, and this is kept on a small pointed pill block like this. It is kept here, and it can be balanced. You can push it like this. If you push it like this, it will just go on hanging like this. It will just, but it will not get out of it, because this this is having shape like this. Yeah, these are its wings. This one and this one is a wing, and this the body and the whole mass of the body is concentrated at this point, at the tip or the nose of that eagle. So we can say that it can be it will be a unique, and it can be inside or outside of the body. Another example, you can say you can see a ring like this, a steel wheel like this. Its center of gravity lies at the center where there is no mass. Another example, a wire is bent like this. Its center of gravity will lie somewhere here, which is 2r upon pi from the base. We will come to know when we are dealing with these shapes in the coming slides. So, the position of center of gravity depends upon the shape of the body. That eagle, it was having a typical shape. That's why that center of gravity lies on the nose of the eagle. It always lies in the plane of symmetry. Plane of symmetry means take this shape here. You can say this is the line of symmetry, because a mirror image of this right hand portion lies in the left hand side. There is a mirror image here, so you can say that this shape is symmetrical about this axis, the y axis. So the center of gravity will lie on this line somewhere. You can say somewhere here, We will come to know when we are calculating the center of gravity of different shapes. Difference between center of gravity and centroid. The plane figure such as lines, rectangles, triangles, polygon, circle, etc. only have areas and no mass or weight. The point at which whole area, length or volume is considered is called centroid. It is usually called centroid of length, area or centroid of volume, etc. Thus, a center of gravity applied to a body having mass and weight, whereas the term centroid is applied to figures having length, area or volume. The method of finding out centroid of the figure is the same as that of finding out center of gravity of the body. The thickness, that is mass of the body, is considered. The CG and the centroid are synonym and pass through the same point. Means if thickness of the body is uniform, that is, if we are not considering the mass of the body, then virtually it is a plane figure. Then we can say centroid and center of gravity are synonym and pass through the same point. Now, location of center of gravity or centroid. The center of gravity or centroid may be found out by one of the following two methods, that is geometrical consideration, by method of moment, and by graphical method. The graphical method is a very tedious, so it is not considered here. We will be dealing by center of gravity, finding the center of gravity by method of moment and by the geometrical considerations. Consider this figure here. This is a plane figure. This shape, this is a shape. It has been broken into number of segments which are having the standard shapes. So find out the center of gravity or centroid of these standard shapes, and then we will be using the method of moment here, which is clear in the next slide. This is the method of moment. As we studied in the Varigan theorem, that the sum of the moment of number of forces of a system about a moment center is equal to the moment of their resultant about the same moment center. So same principle we are applying here. The same corollary can be applied in finding out the center of gravity or of a complex body. The body is divided into number of standard figures and their respective CGs are located from the reference lines using geometrical method. Now the Varigan theorem is applied by stating that sum of the moment of number of masses or weights or lines or segments or volume about the reference axis lines is equal to the moment of total mass or weight or line or volume about the same reference line. Now, when we are dealing with the subject of center of gravity or centroid point, this is a relative position. Consider, for example, if you say that Dosa city is 8 km from where? From Jaipur or from our institute. So we have to give that the reference that from our institute or from Bhandara mode, the railway station is 7 km or 8 km. It is 8 km, you can say. Now, similarly, we have to give a reference that line, define a reference line that from this line the center of gravity is at this much distance. So here is for a plane figure we can define two lines, that is x line and y line, horizontal line and vertical line, and we can say that it is x distance away from the vertical line and y distance away from the horizontal line. So you can say this is the figure, these are the reference lines too, that is this is the center of gravity here. So it is y bar distance from the x line, and this is the x bar distance from the y line, y axis. So first we have to define the references from where we are going to find the distance of center of gravity or centroid. This is the first point we have to consider. Now next, what is considering that this shape is broken into standard shapes. These are rectangles, somewhere triangles, somewhere, and then find out by geometrical method the shape, the centroid of these small segments. Or for example, as we know that for a rectangle, the meet the diagonals of, then they cross at a point, and that section, that point is the centroid of the plane, rectangle or a square. Similarly, if it is a triangle, then you divide the like this, that will be meeting at a common point, then this common point is the centroid of the triangle. By when you find it like this, then you will find that it is, if this distance is say h, then it is h by 3 from the base, or 2h by 3 by 2h by 3 from the apex. This distance is 2h by 3. Similarly, there are different shapes, and in the coming slides you will find the centroid or center of gravity of different shapes. Now let A be the total area of the whole lamina. Let it be divided into number of standard shapes of areas A1, A2, A3, referring to y axis and applying the Bergman theorem here. If whole body is having a centroid x bar distance from the y axis, this is okay. Now if this the total area is A, whole area is A, and the centroid is x bar distance away from y axis. Consider, think again, this is the axis is y axis and this distance is x. Similarly, the axis is x, then its distance is y component. Now consider that they apply the Bergman theorem, which states that the moment of component areas about a reference line is equal to the moment of whole area about the same central line, reference line. Here total area is A, and it is broken into A1, A2, A3, An areas. Then A into x bar is equal to A1 x1 plus A2 x2 plus A3 x3, so on up to An xn. Then x bar is given the summation of whole area An xn, that is A1 x1 plus A2 x2 plus A3 x3 divided by total area A. The A equal to A1 plus A2 plus A3 is the area A. So you can say that x bar is equal to A1 x1 plus similarly An xn upon A1 plus A2 plus A3. Similarly for y bar equal to A1 y1 plus A2 y2 plus so on divided by A1 plus A2 plus A3. Now if it is the mass under consideration, then you can replace A by M. If it is the weight under consideration, then you can replace A by W, and if it is the line segment under consideration, then you can replace A by L, and if it is the volume under consideration, you can replace A by V. For body having mass or weight, the A can be replaced by M or W. Similarly, for A can be replaced by L or V for length or volume. Few numerical problems will clear this concept further in the next slides and in one more lecture to follow. Now, these are some standard shapes, and you can find out the areas, the centroid position of these shapes. For example, for a triangular area, x bar is h by 3 from the apex. If this is the height h, then it is y bar is this much, this is h by 3, or this distance is 2h by 3. Similarly, for semicircle, it is 4r upon 3 pi from the base. This distance is 4r upon 3 pi. Similarly, for other figures, you can refer this like this. The centroid of common shapes of lines. In the first example itself, you will be finding out it like this. The centroids of common shapes of lines. See, this is the line. Yeah, this is also semicircular line. This is the arc of the line. It is for quarter circle arc 2r upon pi, x bar is or y bar also 2r upon pi, and length is pi r by 2. Semicircular arc, that is because the central line it is on the symmetrical, so 1 is 0, that is x bar is 0, then y bar is 2r upon pi, or length is pi r. As you know, for any circle, the length of the periphery is 2 pi r. So half के लिए इसमें it will be pi r only for half length. Now consider this first problem. Here we are finding the centroid of a length L. Find the centroid of uniform wire of length L. It is a wire, so you can consider that it is a plain wire just. Then here these two formulas are given in the integral form. It can be given in the normal form also. summation form also. Here x bar is summation x dl upon summation dl, and y bar is summation y dl upon summation dl. dl is the small length, this much. ठीक है. After integration you will find, or you can find, whole length. When the axis is so chosen that it passes through the center of the wire along its length, then y bar is 0, because it is symmetrical about x axis. Because this wire, if this is the wire, you can say I am showing it, then if your central line is passing through this, then this is x axis, you can say. Then x axis is a symmetrical about this shape is symmetrical about the x axis. So you can say that x bar will lie on this line. So x bar equal to 0. Now consider further, sorry, y bar is 0, not here. Some further summation x dl equal to 0 to L x dl, because length lies from 0 here to L length L here. So after integration you will find summation x dl is equal to L square by 2, and summation dl 0 to L dx. After integration you will find the summation dl equal to length L. So applying the formula, this formula if you are applying here, you will find that x bar is equal to L square by 2 by L, that is L by 2. This is the first simple numerical for finding out the centroid of a wire. Here what we have done, first we have defined the reference axis. Here this is the y axis we have defined, and we have defined the central, this is the y axis we have defined, and central we have defined the x axis. This is x and this is the y. So first of all mark the references, then only you can find the how much is the distance of centroid from those lines. Consider the another case. We would have taken this y bar, the y axis at the central line. Then in that case x bar would have been 0 and y bar would have been b0, because in both the cases it was symmetrical about the x axis also and about the y axis also. So it is your answer will depend upon your reference line you have chosen. Now take the another typical case of wire only. Locate the centroid of the bent wire shown in figure 7.5. Look into the shape. This is the shape of wire like this. This is the straight length, then there is a half circle. So similarly you can say the figure, this 100 mm straight length, then a length of semicircle having a diameter of 100 mm. So total length is 100 plus 100 into pi. This is the total length. Sorry, by 2. So length of the portion AB, L1 is 100 mm. Its centroid C1 is at the center of the line, that is, where is the centroid? Here, somewhere here. How much distance it is there? You have 50 from y axis. It is 50 cos 30. 50 cos 30 from y-axis. If we can say this is x1 equal to, similarly y1 equal to, from the x-axis it is 50 sine 30, that is 25 mm. Length of the semicircular portion L2 pi r is equal to pi into 50, 157 mm. The centroid C2 of the semicircular line is 2r upon pi, that is 2 into 50 upon pi, that is 31.83 mm from the baseline BC. You could have now just see the here. This is the shape. This is the shape. And how much distance it is? It is y bar is 2r upon pi. So now it is the simple formula application. After that x bar is equal to L1 x1 plus L2 x2 upon L1 plus L2. The 100 into 43.30 plus 157 into 136.6 divided by 100 plus 157, which comes out to be 100.3. Similarly, y bar, which comes out to be 59.72 mm. Now this is the numerical based on a plane area. Last two examples are for line and these next two examples are for areas. Consider here the shape shown here. This is the shape like this. We have to find out the centroid of this shape. This shape is like this. So first of all we have to define the reference lines. Here in this numerical the references are taken at this edge and this edge. This is considered x-axis, this is considered y-axis. So we have to find out the area of this figure, and then we have to find out the area of this figure and of this figure, and we have to find out the centroid of this and this, and we have to apply the simply the Varigran thumb here to find out the centroid of this complex shape. Consider how we have done it. For the rectangle, considering whole rectangle like this, he has considered total rectangle like this. Then in that case it is 150 into 150. This is 150, this is a 150. Then total area is 150 into 150, 22500 millimeter square. Then x bar, then x1 is, how much the x1 is? That is distance from here, the central portion, because this rectangle is like this. We know by geometry we can find out that this is the centroid of this rectangle. So how much distance it is? It is 150 by 2 equal to 75 mm. Similarly, from x-axis, that is y1 is also 75 mm. Then for semicircle, The area is pi by 4 d square, you know, the area of a circle. Area of a circle is pi by 4 d square, and for semicircle it is pi by 8 upon d square, or half you can do pi by 4 r square. Whatever you want to say, you can find it like this. So area is pi square by 2. Then x2, as we know, this is the semicircle like this. This is the one like this. So its centroid lies 4r upon 3 pi from the base. From here it is 4r upon 3 pi. So total distance of centroid up to here is 150 minus 4r upon 3 pi. Like this. This distance (150 minus 4r upon 3 pi. Now similarly for A3, this is the area 1, 2 and 3. 3 is this one the area. Then we know that it is x3 equal to 50 plus 2 into 50 upon 3. From here to here, this distance is this much. Similarly for y3 is sorry again x3 equal to 50 plus 2 into 150 by 3. Since this is the distance of 100, this is the 100, this much is 100, so 2 into 100 by 3. Similarly for this distance is 50 only just, so you can say that it is 50 by 3 y3 बराबर x3 b by 3 is 50 by 3, then y3 150 minus h by 3, that is 150 minus 100 by 3, or you can say what I did, that 50 plus this much distance, that is 2h by 300 into 2 by 3, it will be same. Then x bar calculate by using the Bergman theorem, that a1 x1 minus a2 x2 minus a3 x3 is equal to a1 minus a2 minus a3. Here consider this area is negative, this area is negative, and this area is negative. So we have subtracted it from the total area like this. So a1 x1 minus a2 x2, because in quadrant, this is a quadrant, the dimensions towards right are positive, top is positive, is negative and negative, y negative, here x negative. So we can use like this. Similarly, area which is not available, then it is a negative area. So we have done a1 minus a2 minus a3. Similarly, a1 x1 minus a2 x2 minus a3 x3, because areas are negative, that's why the a2 x2 and a3 x3 are negative. If both could have been negative, then we would have been in the second or third quadrant. In that case, they could have been automatically positive. If such a problem comes, I will take in the next lecture like this. So x bar comes out to be 70.94 and y bar comes out to be 68.52. Now next example is 7.4. That is again a typical problem. Locate the centroid of the area shown in figure 7.7 with respect to the area's axis indicated in the figure. Here he has shown the axis. Here the axes are shown, that x, y axis and y axis. This is the y axis and this is the x axis. First, divide the shape into three standard figures. That is, one is triangle, this is the triangle, area A1, then a rectangle, area A2, then a semicircular, the area this much. This is A1, A2 and A3. Now, find the areas and find the x1, x2, x3 from the y bar, y axis, and y1, y2, y3 from the x axis, and then apply the simply this formula. Then a1 is equal to, that is triangle, 3 into 4 by 2, that is comes out to be 6 square meter. Similarly, x1 is this much this distance, that is 5 is the, okay. Then this is 3 by 3, that is 1. So total distance is 6. That is total distance is 6 here. Similarly, y bar, that is y1, is from here, this upper distance, that is total is 4, then 4 by 3, that is 1.33. Rectangular segment, by symmetry you can find out x bar is, x2 is 2.5 and y2 is 2. y2 is 2, x2 is 2.5, simply because this distance is 2 and this distance is 2.5. Half of 5 and half of 4. Similarly, area you can say 5 into 4, that is 20 square meter. Now semicircular segment, that is left to the y axis, A3 is half into pi into r square, r is 2, then 6.28 square meter. Then x5, that is x3 is the distance from this axis to the upward side, that is half of this, that is 2. sorry, again, this is the y and this is the x. X is 4r upon 3 pi. If that is negative, it is negative because this is going towards the left hand side of the y axis. So we have taken the arm as negative, so it is x3 comes out to be minus 0.849. Then y3, that is half of 4, that it comes out to be 2. Then now apply the same formula here, that x bar is equal to a1 x1 plus a2 x2 plus a3 x3 upon a1 plus a2 plus a3. Here this x3 is negative, so this is a1 x1 plus a2 x2 minus a3 x3 upon a1 plus a2 plus a3, because all the areas are real positive, these are not vertical areas. So x bar comes out to be 2.5 meter and y bar comes out to 1.875 meter. Now the last problem. Here we have taken a shape like this. This is the shape of this nature. This is the shape. We have to find out the centroid of this. Similarly, we just divide these two in the two standard shapes, that is A1 and A2. Okay, then find the area. A1 is equal to 160 into 10, 1600 mm square, and then y1 equal to 10 by 2. Because consider this shape, I am making a bit bigger figure, because here like this, you will find that it is symmetrical about the axis, this axis. We have taken the reference that y axis is this is the y axis and this is the x axis, this is the x axis and this is the y axis we have taken. So this shape is symmetrical. Its left hand portion is the mirror image of its right hand portion, so it is symmetrical. Then this x component of the centroid will lie on this line, y line. So we can say x bar equal to 0. Now we are left with only y bar. So for that, just divide this into two sections, that is section 1 and section 2. These are two rectangles. One rectangle is this and other rectangle is this. By symmetry you can find out that its central y axis lie here, because this is the mirror image of this, and its lie somewhere in the center here, 75. And then you know the area, 150 into 10, 150 into 10. Then apply the simple formula here and you will find the solution very easily. A1 is 160 into 10, 1600. Y1 is 10 by 2, 5 mm. For rectangle DEFH, this one, A2 is 150 into 10, 1500. Y2 is equal to 10 plus 150 by 2. How you can say? Again, like this, you can say this way, that this is the 10 plus 75, this much. This is 10. The total comes out to be 85. So now apply the formula. Y bar equal to A1 Y1 plus A2 Y2 upon A1 plus A2, which comes out to be 43.71 from the top. That is from here. And it will be somewhere here. That is, you can say like this. This is the shape. It was like this. Then it will be somewhere here. That is, it comes out to be total is 43.71, this much distance. Thanks for watching this video. Next lecture I will be dealing with some more problems.